Hi, this is our video on methods of data collection, an AP Stats TM instructional video by Zaina, Camille, and Isaac.
Woo woo.
What is a census? A census is defined as a study that obtains data from every member of a population. A population being the group that you want to make inferences about. So basically, a census surveys the entire population that it needs information from instead of just taking a sample to estimate the information it needs. So you survey everyone that you're trying to make inferences about. Okay, what is a sample survey? A sample survey is defined as a study that obtains data from a subset of a population in order to estimate the population attributes. So basically, a sample survey just takes some members of the population, the group that you want to make inferences about, and uses them to estimate things about the entire population.
So, what is an experiment? An experiment is defined as a controlled study in which the researcher attempts to understand cause and effect relationships. So, basically, the effects of a controlled variable on another variable. Experiments use treatments, quote unquote, to observe the effects of a certain variable. So, treatments are basically different values of the explanatory or independent variable, which is the one that we are controlling. To make a good experiment, treatments must be randomly assigned to the individuals in the study. However, random sampling is not necessary. An observational study, on the other hand, is a study that attempts to understand cause and effect relationships, but it is unable to control how subjects are assigned or who gets which treatments. And the way this differs from an experiment is that we are not controlling the explanatory variable, we are just taking a sample and surveying it to look at the effects. Cause and effect relationships.
Scope of inference. So experiments nearly always allow us to make inferences about cause and effect due to random assignment. Observational studies, on the other hand, do not allow us to make inferences about cause and effect, but if they're designed well, we can make inferences about the population. So basically, you can see in this chart here that in order to make inferences about a population, individuals need to be randomly selected, and in order to make inferences about cause and effect, individuals need to be randomly assigned to groups.
All right, so next up, we're going to be looking at an AP free response question from 1999, which was number 3 on the exam. So feel free to pause this video, take a look at the question, and feel free to answer the different parts, and then after you're done, you can unpause this video and we'll go over the solutions together. All right. Great, I've assumed that you've gone over the question. So now for part A, why is this an observational study and not an experiment? So the study is not an experiment because there's no random assignment of subjects to treatments, there are no treatments imposed, and existing data is being used. Thus, it must be an observational study. Now, part B of this question asks for something that we did not go over in this video. However, you can still answer it if you already have an understanding of confounding variables, and the solution for that is right here. Feel free to take a look, however, we will not go over it. Now, part C of this question is if the mean number of new cavities for those who ate an apple a day was statistically significantly smaller than the mean number of new cavities for those who ate less than 1 apple a week, could one conclude that the lower number of new cavities can be attributed to eating an apple a day? The answer to part C is no, because it is not an experiment and cause and effect conclusions cannot be drawn from an observational study. Now let's go over some common errors that people tend to make on this topic. So the first is that students often confuse the 2 types of inferences that we can make. We can make inferences about a population and inferences about cause and effect. It can be easy to mix up the role of random selection and the role of random assignment in a statistical study. Random selection from a population allows us to make an inference about the population based on sample data. Random assignment of subjects to treatments allows us to make cause and effect conclusions. So a great way to remember this is if you take a random sample, you can make an inference about the population. And if you use random assignment for an experiment, you can make an inference about cause and effect. The second error is that an experiment without random assignment is never a good idea. Not only does random assignment create roughly equivalent treatment groups, but it is the basis for the inference methods we use. So a lot of the time students forget that you don't need random assignment for an experiment. However, it is something that is vital to having a great experiment and is something that you should mention when discussing experimental design. Thank you. That's the end.
Thanks for watching.
Yay.
Woo.